So hello, my name is Roman, and today we'll be talking about edge computing. So how many of you are familiar with what edge computing is? Because if all of you are, maybe it's a very short presentation. Okay, anybody else? Oh, okay, so then at least some of you will hopefully learn something today. So I hope at least most of you are familiar with IoT, because it's an IoT track. Historically, if you look at IoT, I mean, IoT has been really more of a domain of just embedded, right? Something that you would basically build on pretty constrained devices. It would be a sort of single-purpose built, piece of hardware, single-purpose built piece of software, typically a real-time operating system or something like that. And none of it would be even remotely relevant to the conference that you're all at today. Because at the end of the day, the conference you're all at today is about liquid software, right? It is about how we can rev up and churn the software on this, on any kind of compute equipment as quickly as we would like. And none of it actually used to be even remotely possible on these IoT devices, right? So in that sense, we're sort of living through a little bit of a revolution. And actually, I was reading this book, that I just got because, I got invited to this conference. And I actually had a, really good sort of slide in there, called Liquidity of Things, kind of, predicting that pretty soon we will be dealing with a lot of Internet of Things that are essentially based on the same set of principles that we take for granted in cloud today, where we would basically try to modify the software in flight. We would try to do rolling deployments, all of the stuff that DevOps, community has developed over the past, 10 years. Now, again, IoT is a tricky term because it has been with us for quite some time, and I think it originated about maybe 10 years ago. And a lot of times, when people say IoT, they actually mean, kind of like Raspberry Pi, people tinkering with their, I don't know, Christmas lights, right, or something. Worst case scenario, consumer IoT, your sort of webcam, but that's not really the interesting part of the IoT. So the interesting part of the IoT these days, and I think this is something that will actually truly push this whole community into more of a liquid, software type of deployments, is this type of IoT. And now we're actually getting much closer to the edge computing. So I actually brought a box with me today. So this is the box made by a German company called Siemens. Siemens, as you should probably know, is one of the biggest, actually probably the biggest industrial manufacturer in the world. It's responsible for not just, your factories and plants, but it's responsible for whole city infrastructures. So Siemens basically builds this box, right? It's no bigger than my palm, right? It has, and you can take a look at it later. It basically has, 3 Ethernet connections, 4 USB connections, and one DisplayPort. And it's definitely sort of looking by the size of it just like Raspberry Pi. So I'm sure you all know how much Raspberry Pi costs. How much do you think this box costs? Any guesses? Anybody? It costs $1,100. And that's the minimum amount of stuff you can put inside the box. Like it's just 2 GB of RAM. So when I tell everybody, everybody goes like, well, why would anybody buy this? And then of course you go back to Siemens and you ask them that question, and they go like, well, we don't know why would anybody buy it. What we do know is that the lead time on this box today, because it just came out to the market in about February, the lead time to get one of these is 4 months. They cannot keep up with the demand at a price point of $1,100 for the cheapest box. Why? Well, very simple, because this box is actually built to withstand environments that your Raspberry Pi will just melt in. This box is tested to be in that environment for at least 2 months. That's the burn-in time, on this box, right? So now we're actually talking reliable IoT. And I think, that actually makes all the difference. Because now the conversation shifts from, well, it's just a cheap piece of compute equipment. And, we don't really have to support it much because, it will probably break pretty quickly anyway. So we're just tinkering with it. No, now we're actually deploying these types of boxes. And, now I'm actually showing you Dell boxes because Dell is very much in that same business as well. Now we're deploying those types of boxes into real critical infrastructure. We're deploying it at, plants, transportation, energy generation. And the hope is that by sprinkling them all over the place, we will essentially arrive at kind of the cloud outside of the cloud, right? Now, basically, everything will have a very reliable piece of compute equipment attached to it, and also actually very capable piece of equipment. Because even this tiniest, box from their product line, like I said, it's 2 GB of RAM. It's actually Intel Atom, fully capable of anything that Atom processors are capable of. It has about, I think, 24 gigabytes of flash. So it's basically now we're talking kind of the size of the computer I used to have in my data center about 7 years ago, right? So now we're actually finally ready for the Liquid software. That's my premise. So this is called Cinematic IPC 127. And you can take a look later. I mean, it's for sure Intel. Now, the reason why everybody is actually interested in deploying these types of boxes can probably be summarized in this slide. By various projections, from Cisco and Gartner, basically the amount of data generated at the edge will pretty soon completely dwarf, the amount of data that actually resides in your data center, and we all will have to deal with it. We just don't know how yet. And what I mean by dealing with it is, we have to deal with it from a legal standpoint. Because some of that data cannot even be transferred to the cloud, even if we wanted to. Like if you're taking, surveillance footage, in a city infrastructure, right? A lot of times you just have legal restrictions on where that data can move. A lot of times just the latency alone would actually force you to deal with that data stream on the device itself. So I think, to me, that is a killer app for an infrastructure like this. And how to build this killer app, nobody knows, which is actually great news for, again, somebody who is very much invested in Liquid software. Because the whole point of Liquid software is to keep iterating over and over again until you actually build something that people can actually use, and it's pretty satisfactory. So a long story short, edge computing is inevitable. But if you look in how we do it today, it's actually pretty abysmal. So again, from the same book, I kind of took the slide where, on the x-axis, we have the update priority. On the y-axis, we have user control, and as you can see, all of the industrial equipment is basically sort of along the bottom of the axis here. None of it is even remotely sort of touching the Liquid software. But again, this is happening. I mean, Siemens is selling tons of these. So as software practitioners, of course, we would have to come up with an answer. And of course, as software practitioners, the answer we would come up with is edge is going to be huge, so let's just wrap some Kubernetes in it, right? Because that's what we do in a data center. How could this be different? The capabilities are kind of the same, so let's just try it. So how many of you have read this report that came out about, I think last year, like mid-year, maybe a year ago, about the ChickfilA guys, trying to deploy Kubernetes at scale at all of the restaurants? Like one person, anybody else? Okay, so ChickfilA basically was faced with the very same problem. So they had these boxes, not particular this kind, but these types of boxes, essentially sprinkled all over the retail chains, retail locations. And then they wanted to orchestrate the experience of the people coming into that retail location, right? Maybe they wanted it to be, let's say, predictive, maintenance, so to speak, of the menus, right? So it's like if they detect that, there are more people coming for a particular type of a chicken, they would actually sort of pipeline, the preparation of that chicken more, right? They wanted to basically do sort of predictive maintenance stuff. And of course, they wanted it to do locally, and there was nothing available, so they came up with this Kubernetes idea. And very quickly, they discovered that Kubernetes is not really built, for that type of an environment. Even though they were okay doing the prototype, I believe that by now that prototype has been scrapped. So another example that you might want to check out again, because what I'm trying to say is the edge is here, so you might as well figure out how to take advantage of it. And let's learn from the people doing it last year. So another example was Cube Edge. This is mostly led by telco companies. Huawei, the Chinese telco manufacturer, is a big sort of proponent of Cube Edge. So Cube Edge was kind of like this idea of a telco sort of guys trying to standardize what Kubernetes would look on the edge. Again, I wouldn't say it completely failed. It actually migrated over the time into the incubator of CNCF, Cloud Native Compute Foundation. but there is not really a big following, because whenever somebody tries to deploy it on anything that's sort of outside of a telco view of the edge, and I will tell you a little bit more about telco, non-telco view of the edge, later on. Again, it's very difficult to use Cube Edge for ChickfilA type of use case. So I think, and this actually came out this year, a few months ago. So I think the only worthy contender, if you truly want to rub some Kubernetes on it, is the K3S from the nice guys at Rancher. So I highly recommend you check it out, because they, for the first time, realized that it's not just the issue of the Kubernetes. So again, what's the issue with Kubernetes? Like, very quickly, it's the fact that the protocol is super chatty. It's the fact that the protocol absolutely doesn't like dealing with the network that is intermittent, and that the implementation is super freaking huge, right? It's like, if you ever ran, an agent on your node, like, it takes space, right? Again, 2 GBs, but still, I would rather not spend 1 GB on just Kubernetes. So K3S guys basically came out with this project, essentially keeping the Kubernetes APIs, but changing the implementation underneath and optimizing it for this type of a use case. So that was one. But I think what was super genius on their part is that trying to deploy it on something like this, they very quickly discovered that it's not just the issue of the Kubernetes, because that's the last mile in deployment. The first mile is like, what is the operating system that is running on this, right? Because so far, people have been building embedded operating systems and like, Yocto-based operating systems. So a lot of times it's not even RHEL that you would find in the data center. It's some god-awful operating system that you cannot even rebuild. And like, at that point, your Kubernetes is completely stuck, because all of a sudden libc is not just quite libc that everybody expected, right? So nice folks at Rancher not only did K3S, which is fine in its own right, and I highly recommend you check it out. In fact, this talk was supposed to be a talk by them, but then they pulled out, so I actually, sort of helping them a little bit here. But I also highly recommend that you check out the K3OS, for operating system. So that's how they're trying to solve in a universal way, basically the first mile problem. They're basically saying like, okay, so the Kubernetes itself has to run on some kind of an operating system. We have to control that, because otherwise we're not really capable of running on whatever is given to us. So they've built a very smart sort of, Linux kind of a distribution, which they then, and again, that's what makes me so excited about their effort, then they basically said like, okay, so just deploying an operating system here is half of the battle. Because again, remember, liquid software, right? So what do we do to actually update this operating system? What do we do to actually protect that operating system? Well, one choice is, go to the same vendors who are selling you all these solutions today to run in your data center. But the trouble is those vendors, again, are not ready to run on these types of boxes. So the K3OS is basically this attempt to say like, well, let's actually extend Kubernetes down. So we've been just dealing at the level of container management, but let's actually extend the API so we can actually deal at the level of even BIOS. So, because remember, there's a lot of software that you don't even think about. There is BIOS, there is UEFI. That also needs to be upgraded from time to time when vulnerabilities get discovered. So they basically say like, okay, let's try to extend the Kubernetes APIs all the way down. And the combination of K3OS plus K3S is basically how you deploy Kubernetes-like APIs on all of these computers, sprinkled in your retail locations. Very, very interesting effort. Highly recommend checking it out. Now, we touched upon it, briefly, but again, let's kind of take a step back and understand, why do the nice folks at Rancher have to struggle with all of these issues? And I submit to you, this is because of this. If you look at the edge requirements, on the surface of it, this box looks a lot like a server I used to have in my data center, right? 7 years ago, but still not that long time ago. That's the stuff on the right. But in a lot of other ways, this box is exactly like this, my cell phone. Why? Well, because these boxes get stolen all the time. These boxes get tinkered with all the time because they don't exist within the perimeter security of a data center. People walk up to them all the time, stick random USB sticks in, they disassemble them, they try to steal secrets, they try to use it as an attack vector into the rest of your IT infrastructure. The list goes on, right? So that's one aspect of it. So just like my cell phone, if I forget it in the bar, needs to be protected, and everything on it needs to be encrypted. And we've developed a whole bunch of operational sort of knowledge of how to do it with mobile. That is one of the big chunk of the requirements for the edge. Another chunk of the requirements, which is even more interesting, again, goes back to the mobile. if you think about traditional data center, the networking is pretty well defined, right? You basically have a guy who defined your topology. You have your top of the rack switches. Yes, sometimes they go down and sometimes you have to deal with it, but most of the time, it's not like on my Android. It's not like you have to hop between LTE and Wi-Fi and back to LTE again, and then to another provider of the LTE, and yet the application that's running on the Android has to still function. None of it is even remotely relevant in a data center setting. So the edge challenges are this unique blend of, how do we deliver software in a traditional data center setting, plus how do we actually protect the hardware and how do we protect the software that's running on these boxes in a very mobile-like fashion. And not surprisingly, Google was actually one of the first ones to realize that, and they came up with this thing called Android Things by essentially trying to extend, just traditional Android operating system to run on the edge. It unfortunately came with its own set of, problems that we will not get into today. But I submit to you that from now on, we will be basically dealing with two types of computers. So one type of computers is computers inside of data centers, and they have a very predictable set of requirements. We know what those are. And when I say data centers, I don't mean your private data centers. A public cloud provider like Google would actually have a hyperscale data center. It's still a data center, right? It still exists as a data center someplace. And then we would basically have all of the computers outside of data centers. And that's, the biggest distinction that we will have to deal with. And to me, that's the definition of the edge. And if you look at Linux Foundation, so Linux Foundation has, by the way, for those of you who don't know, for a long time, they have been completely sort of doing things outside of Linux, spawning these open source foundations, very successful ones. So one of the successful foundations that are dealing with computers inside of data centers is obviously Cloud Native Compute Foundation, CNCF, right? And it's been super successful. Kubernetes is great, absolutely. Linux Foundation has created yet another foundation called LF Edge to basically allow the industry to essentially work on the common set of requirements of what edge computing will be today. And the rest of the talk will be talking a little bit about LF Edge and more specifically about the component that I'm building. So hopefully that will be interesting to you. But before we get there, like I said, edge means different things to different people. So once you leave the data center, first edge that you hit is basically the edge of the, we call it, partial edge, right? This is basically the edge of the telcos, but not true edge. It's the edge of the remote part of the telco network. It's all of the central offices, like these big buildings, that we used to have, to house our telecommunication equipment. These are the COs, and telcos still have to operate them. Now, again, these are sort of computers still inside of data centers, right? Because it's a building that's protected and, telcos own everything inside of it. But it's already outside of a traditional sort of core network of the telecommunication company. So that's, that's the second from the right, right? And then, very quickly, the third from the right, that's the edge of the telco network. That's actually the base station. And, telcos have a lot of angst about, upcoming rollout of 5G, because that's what will get affected the most. All of the central offices will still remain roughly the same, but the base stations will be numerous. If now you have just a single cell tower, now with 5G, you will basically have a base station pretty much at every, street corner, right? So all of that will actually have to be managed. And now then we're actually talking much more of the edge. Because again, these are the computers, that are now much closer to their requirements to something like this. And then, the edge basically bifurcates, and it either gets to be an industrial edge, your city infrastructure, your grid, energy management companies, all of that, or it can be your consumer edge, your house, your home, your car. And Linux Foundation basically decided to take care of all of the edges pretty much from this point on, right? So for the telco, there's a project called Acrano that is trying to take care of a little bit of the CO issues, but mostly about, the base stations and all of that. And then there is the project that I will be talking about called Eve, Edge Virtualization Engine, which is for the industrial edge. And then there is a Samsung project called Home Edge, which is, again, not surprising given that it's the company that produced pretty much all of your, washers and dryers and fridges and all of that. Now, in the middle of it, there's a little bit of the middleware. So EdgeX Foundry is that middleware that is sort of close to, if you know what Cloud Foundry is. It's basically kind of like Cloud Foundry for the edge, where they try to basically abstract you as a developer away from some of the concerns, but those are just middleware concerns, right? Just like Cloud Foundry and Spring to some extent would abstract you away from what a database is, EdgeX Foundry would abstract you away from, let's say, what a sensor is or what an industrial protocol is, because apparently there is a lot of industrial protocols, and you actually want interoperability between them, and it would be nice to have a middle layer that would actually be able to translate between them. So that's exactly what EdgeX is. Now, I will be talking about the Eve Edge Virtualization Engine. And if you want a little bit more of a functional view of the Linux Foundation projects, there's actually quite a few of them playing in the edge space. So obviously, again, the big projects are Crano, Eve, Home Edge. But there's also, kind of like I call them infrastructure projects. So there are, hypervisors, for Acorn. There's different kinds of operating systems, specialized one like Zephyr. There's Photon OS, which is a much more constrained operating system. So there's actually quite a few projects in the Linux Foundation that are coming together to sort of create this LF Edge. By the way, LF Edge is super new. So it just got created in February this year. So we, made a big announcement and all of that. So people always tell me like, well, it doesn't look as exciting as CNCF. And I'm like, well, CNCF didn't look that exciting, when it just got started. So again, will it get to be as exciting as CNCF? Well, if you join, it will be. But if you don't join, it won't be. So it's actually a pretty simple proposition. So within this big ecosystem, we have, my company and sort of the open source project that I lead, we focus on the industrial use cases. So again, boxes like these. And just to recap, some of the basic principles, like I told you, we need to build an infrastructure that is essentially in business of running applications, right? So the first question that we have to answer is, what is an application, right? Because again, coming back to my Android analogy, that was one of the biggest benefits that Android brought to the developer ecosystem. Because before Android, an application could have been a BlackBerry application, or a Nokia application, or an Ericsson application. Oh, by the way, every single one of them actually had different profiles, so it would be different applications even within those families. With Android, yeah, sure, there are different hardware profiles, but most of the time it's just an APK, right? My application as a developer, I'm done building my APK. I will upload it to Play Store. I'm done. So we need to define what is it that actually means to be an application on the edge. And for that, within the Linux Foundation Edge, we're standardizing this idea of an edge container. So edge container is meant to be an extension, just a true extension of the OCI, traditional sort of data center open container initiative container format. But it also is meant to embrace things that, again, are not super relevant in the data center. On these boxes, you still have to run real-time or close to real-time operating systems. So whatever it is that you do in terms of packaging it, it has to support a real-time operating system. Now, again, we feel like we actually have a pretty good answer to how unify containers, VMs, and unikernels. And that's what the edge containers will be all about. Now, once you define the application, once you define basically your packaging and distribution format, the rest is easy, or at least it's supposed to be. It just needs to run on something, and then you just have to define what are the properties of that something that it runs on. So for Eve, we basically submit to everybody that it actually has to have three basic fundamental properties. So it has to be zero touch, in a sense that this box, well, this particular one actually has a display port. A lot of them don't. And the ones that don't, they wouldn't even have a serial connection. It truly needs to be zero touch. You basically bolt it onto your ceiling, you turn it on, it needs to function. So the joke, within our open source project is that we basically need to operate a little bit like botnet, like those viruses that infect your computer, because those can function anywhere. Like they don't really ask you like, hey, what's my Wi-Fi password? Or like, help me with this or that. They just run. So whatever we build for these boxes basically has to be like a botnet. It has to run anywhere, everywhere, and be absolutely zero touch to a point where you wouldn't even know that it's there, just like you don't know whether botnet has infected your computer. It has to support any type of the application. Like I said, real-time applications, there are containers, traditional containers. But it also has to support, any kind of hardware. So hardware heterogeneity is still pretty high on the edge. It's getting better, but it's pretty high. And it also has to support any kind of network. Because again, remember the Android analogy, right? This little guy actually has to hop between LTE and Wi-Fi all the time. But that's not the worst of it. The worst of it is when it's on Wi-Fi, it's basically guaranteed to be behind a few net boxes. So sending data to it becomes a real issue. It can make outgoing connections, but actually routing to it becomes a really, really big issue. And as I discovered, building this project, apparently routing to an LTE IP address is actually a big issue as well. So you kind of have to figure out, in the networking environment that these guys will exist in, what is the answer to the developer? Because developers would hate figuring out, how to punch holes in the firewalls and how to traverse netboxes. So whatever it is, you actually have to give a developer an API that would just work. And finally, these boxes, like I said, they have to be zero trust in the sense that just like your cell phone, whatever ends up running here has to be protected, and the box itself has to be protected from the application. So based on these principles, we feel that we actually have a pretty good view into how this whole ecosystem is going to evolve. So if you take an example of a mobile operating system or the cloud, there's always two, right? There's an open source and there's closed source, number ones, right? Android and iOS, it pains me to say it, as a Unix guy, but I have to say that in the cloud, the open guys are Azure now. Like, it's true. I mean, I have to say it, hate to say it, but it's true. And, AWS is an evil empire. So on the edge, we feel that as a community, we would actually build the edge virtualization engine, Eve. And who will emerge as an evil empire? That's actually a really big question. I don't know. I mean, it could be Google or Amazon, could be, but it actually could be somebody like VMware as well, so we just don't know yet. Now, with the project itself, so again, the approach that we're taking is we have all of the siloed system right now that are built as an embedded, type of development. So what we're trying to do with them is we're basically trying to take all of the software functions out of those siloed systems, be it a real-time operating system or just an set of containers that are running on your Raspberry Pi. And we're trying to run it on a common infrastructure that can run on any box like this. So this common infrastructure, this sort of call it an operating system and an operating environment, that is what Eve is, right? So Eve is basically something that runs on the box. It boots, it runs on the box. And then it can support these types of workloads and essentially providing a really nice software type of environment for these types of workloads. Obviously, once you build something like that, it actually needs to be controlled because all of a sudden, like I said, I mean, these boxes basically have nothing but a network connection to them, right? So how do you schedule workloads? How do you manage the boxes themselves? All of it actually has to be controlled from the cloud. So the box itself will have an API to the cloud, but the cloud itself will also have an API for sort of management of the workloads. And that's where the Kubernetes kicks in, because that front-end API could totally be Kubernetes. Like your kubectl can talk to basically a controller in the sky that would then dispatch workloads in these boxes. The API between the box and the controller is something that LF Edge is now standardizing. So again, if you're interested, absolutely join us. It's actually interesting because it's this weird mix between like a puppet chef type of a thing and like a cloud type of a thing. It's actually very interesting how it's evolving. But at the end of the day, the experience that we want to give to everybody is very much cloud-like, right? So you basically have Diane, the DevOps, and she will be deploying the workloads, on this type of hardware completely indistinguishably from her deploying these workloads on Amazon or Azure. Like I'm saying, I would love for the API, for this front-end API, right? The cloud API to actually be something standard as Kubernetes. That would actually make sense to me. But the open API between the project Eve and the Eve controller, it's a very specialized one. So just keep in mind that there are two APIs. Just a very short plug for my company, because I had to have the obligatory slide. So we ourselves, essentially invest heavily in the bottom layer, which is fully open source. Every single bit of software that runs on the box is open source. The stuff that we write ourselves is Apache licensed. The stuff that we take from other open source communities is like GPL or BSD licensed or whatever else, but like fully open source, nothing proprietary whatsoever. Then the company itself monetizes the controller. So we hope to build the most scalable controller in the sky so that once you have Eve running on the box, your choice of what controller to hook it up to will be the default one, ours, ZEDEDA. But we're also fully expecting other companies like Google's and Amazon's and Microsoft. Actually, we're in talks with Microsoft about this to build their own controllers and integrate it into their own cloud platforms. So that's sort of the overall play. Now, one question that I get asked all the time about Eve is like, well, you making this Android analogy so much that like, okay, so what's wrong with Android? And instead of telling you what's wrong with Android, I will actually tell you sort of the similarities, because in a lot of sense, we basically had to answer the same set of questions, for building Eve. And the set of questions is application and operating system sandboxing. How can you protect applications from each other, and how can you protect operating system from the application, and vice versa? Application bundling, again, what does it mean? What does it mean to actually be an application? Application deployment, how it is that you actually deploy the application, and finally, what hardware we support. So if you look into Android basically made all of the choices that made sense at the time, right? So for the app sandboxing, it was JVM, made perfect sense at the time. We're actually using hardware-assisted virtualization, completely same stuff that you would use for VMware or Xen or KVM. That is now the default in every single one of these types of boxes. Application bundling, again, Android was, obviously APK. We're using this idea of edge containers. For app deployment, we're actually following a very similar model. So our idea is that we will actually have App Store-like, experience for these types of applications, right? So again, suppose I am managing an oil field, or I'm managing, a field of wind turbines. As somebody who operates that field, I would like to have the best software to do predictive maintenance on my field. And today, every single time I have to do it, it basically turns into this huge system integration effort, because I have to invite the company, they have to build it for me as a one-off, as a, What if instead of that, we basically had a marketplace where those types of applications could be traded? And the only requirement for those types of applications would be, well, as long as it runs on Eve, that's all we have to know. Just as much as, again, as long as it's part of the App Store, that's all I have to know. Interestingly enough, on the hardware side, with Android, again, all of the choices that made sense at the time, we're kind of sticking with the same set of choices, by the way, but one bit is different. So we're both supporting Intel and ARM, obviously, but MIPS sort of turned into RISC-V. How many of you do know about RISC-V? Okay, so RISC-V is this really awesome architecture that is fully open source. It traces its lineage to the same people who gave us MIPS, basically, guys and gals from Berkeley. And it's the same research team that basically decided to come up with a completely patent unencumbered, set of design and VHDL descriptions, for this new CPU called RISC-V. There is a tremendous amount of excitement in the industry. So companies as big as Western Digital and Seagate are essentially transitioning en masse to RISC-V because you pay 0 royalties. RISC-V makes you pay 0 royalties. It's all licensed under the open source license, right? And if any of you or you have in your extended family CPU geeks, RISC-V is one of the best sort of CPU implementations to actually develop for, because one of the things that they came up with in order to bootstrap the open source community, they're like, well, not a lot of people can actually do VHDL, because in order to do VHDL, you actually have to buy these really expensive tools. And it's like by the time you invested 10K into the tools, like you are probably not an open source developer. So they actually came up with this DSL, domain specific language that's based on Scala, that allows you to actually hack the implementation of the CPU itself without ever thinking about VHDL, which is actually super awesome. But I digress. So my point is, I think the edge on the upper tier, something like this will belong to Intel. So Intel is actually moving, very rapidly in that space. I hate to say it, but I think ARM will lose. So we will still support it because it exists. But I think between the RISC-V and ARM, my money is on RISC-V. So that's why we're sort of betting on both. ARM obviously today is very much present, so we have to support it. So let's quickly talk about what Eve actually sort of does or what it offers to you as a developer. And then I would like to make it as interactive as possible and maybe take some of the questions. So at the end of the day, again, think of it as a very traditional virtualization environment, right? So Eve runs on the type 1 hypervisor. So today it's Xen. We are talking to Linux Foundation project called Acorn. Acorn is Intel's attempt at essentially building an embedded specific hypervisor for Intel. So pretty cool project. So we might actually support that as well. But it basically runs on the type 1 hypervisor. And on top of the type 1 hypervisor, it supports all of these types of workloads, like I said, that packaged as edge containers, right? Now, the cool thing is that because it runs on the hypervisor, at this level, which is sort of, I call it on the other side of the hypervisor, we can do a lot of tricks that today typically associated with sidecars. So how many of you do know what a sidecar, either Kubernetes-wise or like any other? Okay, so at least a decent amount here. So very quickly, a sidecar is a container that is basically a system-level container that provides a certain function to your application container. So let's say your application container doesn't want to deal with load balancing. So then all you have to do is run a sidecar, and that sidecar provides a listener on a local host, and the sidecar itself deals with the load balancing. The application itself only ever opens up a connection to localhost. It doesn't have to even know where the traffic is coming from. So that's sort of the whole idea of the sidecar. We can do a whole bunch of tricks like that on the other side of the hypervisor in a much more efficient way. And my favorite one, which I will throw here just as an example to give you appreciation of what Eve is trying to do, is basically connectivity. So when we deploy a VM, one of these workloads, right? Because we're running on top of hypervisor, to a VM, a network connection that we're giving to a VM would look like a virtualized Ethernet adapter. So when the VM boots, it just sees that there is an E2000, for those of you who remember. No, it's actually different, but pretty similar. That it can drive, with just single, driver. A lot of times it's actually a VirtIO driver, which makes it even more efficient. But it's basically a virtualized network interface card. But what application doesn't have to know is that what kind of magic we will be pulling off on the other side of the hypervisor. So all of a sudden, that virtualized network interface card becomes an interface to a sidecar that we will be running on the other side of the hypervisor, which allows us to pull some really neat tricks. So for example, today, one of the big deals on the edge is if I run application on this box, a lot of times, the backend of my application would run in the cloud, right? On Amazon or Microsoft or Google Cloud. So the question then becomes, how do I configure my networking so that I become part of the VPC, let's say, that's actually part of the Amazon cloud? And the answer to that is, well, if you're running just a random Yocto-based distribution, you're actually out of luck. Because chances are that strong Swan, which is IPsec implementation, which is what VPC on Amazon happens to be, will be incompatible with your distribution of Linux. At which point people get stuck. They're like, okay, what do I do? Like, I have this distribution of Linux, it runs on my box, I have to make sure that it talks to those machines on Amazon. So then Eve shows up, and we're like, well, easy. Take your existing application, don't modify anything, right? Just virtualize it, put it inside of a VM. Your application will think that the traffic coming to it, through that interface card is the traffic just like any other traffic. On the other side of it, we will make sure that we basically strip everything from TCP/IP up or TCP/IP down, and we will basically encapsulate it into IPsec traffic, send it back to the Amazon that you configured, and your application doesn't even know that we're doing it, right? So all of these tricks that we can do actually resonate really well with developers, because the biggest thing that they are struggling with right now is they all grew up in this world of embedded development where the resources were super constrained. So doing something interesting and tricky wasn't even an option. Now that they have to connect that stuff to the internet, they're like, okay, what do we do? Can we at least have the stopgap solution where we take the existing stuff, run it on something, anything, that would actually allow us connectivity and all these other properties, right? It is actually not dissimilar to what was happening in a data center when virtualization got introduced, because for those of you who remember, the biggest use case for VMware at the time was actually Windows NT. Windows NT was sort of running out of steam, hardware support-wise, and VMware showed up and said like, well, you can take it, virtualize it, and we'll run it as a virtual machine, and your base OS, your host OS, can be whatever. Like, it can support the latest drivers and can do networking however it wants, but your Windows NT will not even notice because we will emulate and virtualize everything for you. That is the most fundamental use case that people who are trying to migrate from the IoT to the true edge computing are now sort of struggling with. So Eve itself is actually composed of multiple different pieces. So there's a lot of documentation on the Eve's website. You can just Google, LF Edge Eve, it will come up. But it's, it's an operating environment, pretty complex by now, but still pretty tiny. So the smallest, compute box that we can run on is Orange Pi, which is actually even smaller than Raspberry Pi. But there's not really enough, room left for interesting applications. So you're probably looking for something like this anyway. And that's it. That's pretty much all I wanted to tell you. so that I have at least some time for questions. So any questions? Or you can take a look at the box and come up and, Mm-hmm. Oh, like IoT specific? Okay, awesome, awesome. Yeah, that would be nice. Yeah. Yeah, we can then move upstairs and kind of like, maybe participate in a bigger group. Yeah. Mm-hmm. Yeah, so I think we will be, so that's actually why we're embracing this idea of unikernels, very rapidly. So unikernel was this idea that we can actually slim down even containers even more, right? And in the data center, it was a little bit of a solution looking for a problem, because containers ended up being small enough for people not to care to make them even smaller. On the edge, I think unikernels will be a big deal. So two pointers that I would give you are look up two things. So one is called Atman, A-T-A-M-A-N, Atman OS. So that's basically a Go community, Go language, a community project of allowing Go to run without an operating system. And it's actually really cute how they do it. So if you have anything that's Go, right, you know how now you can basically specify Go OS, and essentially you're doing cross builds, for that OS. They implemented an OS that is basically a hypervisor. So you can specify Go OS equals Zen, and the executable that will pop out will be an executable that doesn't require a single bit of an operating system. It's highly, optimized. So if we can start moving towards those types of executables, I would actually, I would totally see a lot of the containers basically running on the same device. Yeah. All right, awesome. Thank you so much.